Question 3 says a heat energy absorbs 5,000 joules of heat and releases 3,000 joules to the sink. Calculate its efficiency. Option A, 40%, option B, 50%, option C, 60%, and option D, 70%. They said we should find this what? Efficiency. Efficiency measures how well heat is converted to useful work. It is given by the formula efficiency is equal to QH minus QC all over QH times 100, where QH here talks about the heat absorbed from the hot source. Heat absorbed from the hot source. QC here stands for the heat rejected to the cold sink. Heat rejected to the cold sink. Efficiency here. Don't forget the unit for this is joules. The unit for this is joules. This symbol here stands for the efficiency. And efficiency is in what? Percentage. From the question it says a heat energy absorbs 5,000 joules of heat. So our QH, don't forget, is what? Heat absorbed from the hot source. We have 5,000 joules. Our QC releases 3,000 joules. So we have QC 3,000 joules. They say calculate its efficiency. The efficiency is unknown. If we impute this into this equation, we have efficiency is equal to QH minus QC all over QH times 100. This is equal to our QH is 5,000 joules. So you see 5,000 minus QC is 3,000 divided by this is 5,000 times 100. 5,000 minus 3,000 gives you 2,000 divided by 5,000 times 100. This cancel this will cancel this cancel this. You have 2 over 5 times 100. 2 divided by 5 will give us 0.4 times 100. 0.4 times 100 gives us what? 40. Don't forget the unit for efficiency is what? Percent. Therefore, the efficiency of this machine is what? 40%. We have the efficiency to be 40%. Question 4 says a projectile is launched with velocity 40 meters per second at an angle of 30 degrees. Calculate its total time of flight, given that g, which is acceleration to gravity, is 10 meters per second squared. Option A, 2 seconds. Option B, 3 seconds. Option C, 4 seconds, and option D, 5 seconds. Now, time of flight depends on the vertical direction, and it is given by the formula C is equal to 2u sine theta over g, where t here stands for time of flight. Time of flight. U here, this is in seconds. U here stands for initial speed. Initial speed in meters per second. Theta here stands for the angle of projection. And it is in what? Degrees. G here is acceleration to gravity. Due to gravity in what? Meters per second squared. Now let's check what we were given in the question. In the question they said a projectile is launched with a velocity of 40 meters per second. So we have u to be 40 meters per second. You see, at an angle of 30 degrees, we have theta to be what? 30 degrees. 30 degrees. You see, calculate its total time of flight. C is unknown, but they gave us G. Acceleration to gravity to be what? 10. 10 meters per second squared. Now from this equation we have what? Sine theta. Sine theta is equal to, theta here is what? 30 degrees, so we have sine 30 degrees is equal to 0.5. Yet if you push it to your calculator you have 0.5. If we substitute all these into this equation, we have T is equal to 2 times U. Our U is what? 40 meters per second. Times sine theta. We know that sine theta here is what? Sine 30 degrees, and sine 30 degrees is 0.5. So we have this here. Divided by G. Our G is what? 10 meters per second. So we have 10 meters per second. 2 times 40 will give us 80. Right? 80 times 0.5 will give us what? 40 divided by 10. 40 divided by 10 gives us 4. Therefore, the time of flight is equal to 4 seconds. Don't forget, time is measured in seconds. Therefore, our correct answer here is option C, 4 seconds. Question 5 says, 2 waves arrive at a point with path difference of 1.5 pi. What is their phase difference? Option A, pi. Option B, 2 pi. Option C, 3 pi. And option D, 1.5 pi. Now, for phase difference due to path difference, we have the formula. Change in phi is equal to 2 pi times change in x all over lambda. This is the formula for what? Phase difference, where change in phi is equal to the phase difference in what? Radians. Change in x here talks about the path difference in meters, and lambda here stands for the wavelength, also in meters. From the question, we are given the path difference to be 1.5 lambda. So we have change in x to be 1.5 lambda. They say, what is the phase difference? The phase difference is unknown. It's unknown, we don't know it. If we substitute this into this equation to get the phase difference, we have that the phase difference is equal to 2 pi times the path difference divided by lambda. From the question, they gave us the path difference to be 1.5 lambda. If we substitute it here, we have 2 pi times 1.5 lambda divided by what? Lambda. 2 times 1.5 gives us what? 3. So we have 3 pi lambda divided by lambda. If we multiply this throughout, we have 3 pi lambda divided by lambda. Lambda will take away lambda, we are left with 3 pi. Therefore, the phase difference is given as 3 pi. The units for phase difference is what? Radians. If we come to our options here, we have option C to be correct, 3 pi. So this is the final answer.